Well, how's it going there, Algebra 2 class? I want to start by saying that this is some pretty crazy times we're in. My number one priority, I hope you guys are doing all right. Um, your health and well being, I know this can be super difficult, and I don't know what each and every one of you situation is, but just let you know that I'm thinking about you guys. It just seems weird to think that we were only in class for like what 1 or 2 weeks. The trimester had just started, and before this all happened, so we haven't really been in class together very long. And that's too bad. I mean, I already miss you guys. I don't have to know you that well to just miss you and miss being in the class and getting to know you and trying to let my personality come out that you can get to know me and yeah. So um, basically, I'm going to continue to try to I'm going to try to send out videos to you guys on a weekly basis. It might be a video or two depending on the topic. Um, the Algebra 2 teachers, we all got together on a Zoom meeting session and discussed what do we want to cover by the end of the school year, because after spring break, which is when you'll probably be video or viewing this video, we will have 7 to 8 weeks left. So we kind of have like, I want, a weekly, let's get this done this week, let's get that done that week, and so on. So this first week back from spring break, um, we want to get done the section, I believe it's section 7.3 if we look in the textbook, on simplifying rational expressions. Now the key to that is knowing how to factor. So just before this extended break, we had spent the week factoring and doing multiple worksheets. And last week or two ago, I sent you a link with 3 worksheets that I hadn't actually given you before, so that you were looking at something new. I'm going to be working for those worksheets right here today. And this video is just going to be a quick review of factoring. I'm going to pick some problems off of this. There's one on front, one on back, and the third one right here. I'm just going to work some of those examples out to have you kind of remember, like, how do I factor, and then you can use this to, maybe practice a few of these. And, if you're like, I don't have access to a printer, you don't have to. Just, if you can pull this up on an email of some way, whether it's your Chromebook or your phone, and I'll resend these worksheets with this video. But just to work them out on paper, just to look at them, they don't have to be a printed copy in your hand. Just something that you can write these out on and factor, and then we'll the next video we'll start actually talking about doing that section, simplifying rational expressions, and that's all we'll do for the first week here. We're just going to do that one section. That's it. So let's not stress about that. We'll keep the learning reasonable. I'm trying to make it stress-free, and hopefully, I set myself up a couple of whiteboards in my basement. I mean, I know we were only together a short time, but that's how I work. That's how I operate, and I'm a whiteboard kind of teacher. I don't like being behind the document camera or anything like that. And so this is my strong suit, and I hope you can enjoy this at least a little bit, a little normalcy. But anyway, on this left-hand board, let's get down to some business, huh? I have just a couple of reminders. I'm going to simplify this a little bit, and these worksheets reflect what I'm going to tell you today. This is a little factoring checklist. It's a flow chart. It's not a how to do a factoring. That kind of falls on you, and I'm going to re-explain a couple of things. But we're only going to do 2 kinds of main factoring. You're either going to have a binomial, meaning 2 terms, and those will be what's known as difference of squares. I know in class we had talked about sum and difference of cubes. I'm going to just take that right out of the picture. And then we're going to deal with trinomials. That's either something that's x squared, then an x, then a number, or a ax squared, meaning there's a number in front of the x squared, x number. They're similar, but the ones with numbers in front are a little more challenging to deal with. So we're going to talk about that. Right at the top of the list is greatest common factor. So in a minute here over here on this board, I'm going to just review a few factoring problems. That's the first thing I'm going to look at is there a greatest common factor to my problem? Okay? So I'm going to start with the binomial type examples. Now, the binomial examples, please remember, they were called the difference of squares for a reason. It's just not a name. Difference means subtraction. Squares means perfect squares. I wrote a list of perfect squares right here. Now, if you're watching this on a computer screen, or if you're even watching it through a smart TV or a Roku or something like that that's on a TV screen, way easier to see than if it's on a phone, I think, personally. But you can see this is the first 15 perfect squares. 1, 4, 9, 16, 25, etc., all the way through 225. And just understand I got those numbers by doing 1 times 1, 2 times 2, 3 times 3, 4 times 4, all the way through 15 times 15. So difference of squares means subtraction of perfect squares. That's what we're going to be looking at right now. This is the first worksheet, like the one's called 3-1 factoring. The other one you got was called 3-1 factoring, but it had a little 2 in the corner. And then this one was called factoring 3. It was up there. So I'm going to take all these questions that I'm going to talk about today from the first page. That leaves the second and third page for you to practice if you need. So here's the first problem off that page, number 1. It's the binomial x squared minus 81. So number 1, greatest common factor. Doesn't have a greatest common factor. The leadoff coefficient right here is a 1. 1 can't be reduced lower, so if 1's part of the picture, no greatest common factor there. And the other greatest common factor that can exist is if there's an x involved in the whole problem. Well, x is in this term, but x is not in that term. So greatest common factor is off the table now, and we go to our binomial thing. Our binomial thing is difference of squares. Is it subtraction? Yes. Is everything a perfect square? Yes. X squared is x times x, and 81 is 9 times 9. It's right there on the list. So this factoring method breaks up to this. X and x, plus and minus, 9 and 9. X plus 9, x minus 9. And you guys please remember, I think the biggest deal here is that gets lost on students. It's not so much about, oh, memorize that pattern, there it is. Yes, unfortunately, there's a little memorization to this, but you should be able to check this answer. The distributive property checks it. See, factoring and the distributive property are opposites of each other. We talked about that, but I got to refresh your memory. It's been weeks now. Okay? So if I was to distribute this all out in combined like terms, I'd get exactly x squared minus 81. Specifically, I would get x squared minus 9x plus 9x minus 81. But the minus 9x plus 9x would cancel, leaving me only x squared minus 81. There's the factoring. Question 2 on that same page is 9x squared minus 49. Now, same deal. I should start with greatest common factor, GCF. Now, the GCF is based off the smallest number, which is 9. So I ask myself the following questions. I know 9 goes into itself, but does 9 go into 49 evenly? Oh, that's a no. If I check it on a calculator, it's a decimal. Be careful, though. There's another number that goes into 9 evenly, and that's 3. But 3 does not go into 49 evenly, so no GCF again. GCF's off the table. So this is a binomial. I only got one thing to know. Is it difference of squares? Is it subtraction? Yes. Is everything in the question a perfect square? That's also a yes. 9 is 3 times 3. X squared is x times x. And 49 is 7 times 7. So those are all yeses. So the factoring goes as follows. 3x for the 9x squared, plus minus, and the 7 and 7, 7 times 7 for the 49. And there is the factoring of that. Very similar two problems. I just incorporated a number in front of this instead of it just being x squared to remind you of that. Okay, now I'm going to go right to the third question before I change gears. The third question, and it's right on the worksheet, is 20x squared minus 45. Now, this is a popular one when I'm in the midst of teaching factoring for the first time, that people will write not factorable on the test or quiz or assignment. And that's because people don't do the GCF. That's a very popularly missed step. So we're going to do greatest common factor, and you guys, spoiler alert, this one's got one. This has got a greatest common factor. The numbers 20 and 45, 5 goes into them evenly. Now, x is not a part of the greatest common factor because the x is here, but the x is not here, so it's just 5. So I'm going to pull a 5 out front, which means divide 5 out of each factor. So 20 divided by 5 is 4. That leaves me 4x squared minus 5 goes into 45 9 times. And you guys, this leftover binomial, so now here's the difference. I did my GCF, done, checked it. I'm in a binomial situation, so the binomial that's left, my question on the table is it a difference of squares? Is it subtraction? Yes, it is. Is it perfect squares throughout? Yes, it is. 4 is 2 times 2, x squared is x times x, and 9 is 3 times 3. So, leave the 5 where it is, and break this up into 2x plus minus 9 is 3 times 3. See, when you reach the end of the flow chart, you're done. Like if it's, GCF, okay, do it. Is it a binomial? Okay, check for difference of squares. If it's a difference of squares, do it. And for us, because we're just kind of trying to keep things reasonable, that's the end of the road. Okay, you're done. There's your factored deal. Okay, so that's my little spiel on remembering greatest common factor and binomial difference of squares. Okay, now I am going to erase this. It's very easy for you guys at this point, like, oh, I need to see that a minute. Well, pause the video anywhere you want, back it up later. It's not going anywhere in terms of the video, and if you need to write anything down or whatever, you can. But now I'm going to just erase this a quick minute, and we're going to get into some trinomial stuff just for a few minutes. A little bit harder to talk about because there's a little bit more open-ended with the trinomials. Okay, so the first trinomial example I'm going to pick off is right off of the worksheet as well, number 4. I'm just kind of working in order right here. I don't know that I'm going to do the whole worksheet. I'm just going to kind of pick some tough stuff, or some representative stuff, I should say, not tough. So question 4. Question 4 is x squared minus 4x minus 32. So we have ourselves a trinomial now. So now everything we talk about, we got to talk about in terms of 3 terms. Still start with the greatest common factor, and here's a couple of things to notice about this. The leadoff number is understood to be 1, which means no number greatest common factor. And because there's 3 terms, but the x isn't in the third term, x isn't part of the greatest common factor either. So we're going right into, this is trinomials. Now, there's no fancy name. It's just trinomials of the look, x squared followed by an x followed by a number. I think in class I referred to them like, that's got the look. X squared, x number. You break this up into 2 parentheses. This must be x and x. The number in this first slot and the number in this first slot, or in this case the variable, has to multiply to be that first term. The number here, the second position, and the number here, this parenthesis second position, has to multiply to negative 32. That's the requirement. Now, what comes to mind most of the time is 8 and 4. So somebody might write plus 8 minus 4. And it must be something like plus 8 minus 4, otherwise it doesn't multiply to negative 32. It can't be 8 and 4. It can't be negative 8 and negative 4. Those things multiply to positive 32. Now, again, spoiler alert, that's wrong. I wrote it wrong on purpose, because I haven't said anything about this minus 4x in the middle. So you guys, if you were to distribute this right now, it should match to this. And here's the deal. The x times the x does give me the x squared. The 8 times the minus 4 does give me the minus 32. Now, I did this in class. This and this part of the distributive property make up the middle term, because see, those parts of the distributive property create like terms, which are responsible for the middle. X times negative 4 is negative 4x. 8 times x is positive 8x. Folks, negative 4x and positive 8x combine to make plus 4x. So close. All this requires of us, sign change. Minus there, plus there. See, still negative 32 on the multiply part, and this is now 4x, x times 4, 4x, and negative 8 times x, negative 8x. Folks, 4x and minus 8x, 4 minus 8 is negative 4x. We got ourselves a match here. So that's what we're talking about in terms of trinomials. So, just taking ourselves a little bit of step up, let's go right to question 5 off the first worksheet. We are talking about 3x squared minus 33x plus 72. So, number one, I'm not changing my path ever. I'm trying to be consistent. Number one, look for a GCF. I don't care if I have a binomial or trinomial or whatever. Check for a GCF. Now, the littlest number in the question is 3, so right now I'm questioning 3. Is 3 the greatest common factor? Well, I know that 3 obviously goes into itself. Because this is 33, I know that 3 goes into 33. Now suppose I didn't. I'd unfortunately have to get out a calculator and say, hey, does 33 divide by 3 evenly? Well, it does, 11. This might be one that we just like, yeah, I don't know this one. Does 3 go into 72? Now, I left my calculator upstairs, so we're gonna wing it here. I should be able to wing it, shouldn't I? Does 3 go into 72 evenly? So let's see, 3 goes into that twice, 34 times. Or excuse me, 24 times. 24 times. So we are going to take out a 3. 3 goes in there, leaves me 1x squared. 3 goes into there, leaves me 11x. 3 goes into there, leaves me a 24. Folks, we still got ourselves a trinomial that needs our attention. This trinomial resembles, not exact of course, resembles number 4 up here. So we're going to attempt to factor this. Leave the 3 out front. Because that's x squared, make it x and x. Okay, now some thinking ahead. The two numbers I place here and here have got to multiply to positive 24. But there's a negative 11 in the middle. Now you got to understand, it just can't all be plus and plus. How does a negative come into there? So this is automatically going to be minus and minus. Okay, now you guys, a lot of things can go through your head right now because there's lots of ways to multiply to 24. There's 1 times 24, there's 2 times 12, there's 3 times 8, and there's 4 times 6. I'm not going to sit here and make one mistake after another. I mean, this is a video, but I told you the options you could check. 3 out of those 4 things that I mentioned, 1 and 24, 2 and 12, 3 and 8, 4 and 6, 3 out of 4 are going to fail. The 3 and the 8 will pass the test. And you guys, am I just saying they passed the test because I'm saying it? I know how to check, and so do you. I'm not special in this. You know how to check this. The x times x is x squared. Then negative 3 times negative 8 is positive 24. Remember, it's this, I didn't write it this time, it's that outside group and that inside group checking this negative 11. Well, x times negative 8 is negative 8x. Negative 3 times x is negative 3x. Folks, negative 8x, negative 3x make negative 11x when combined. We have a check. So there's that factoring. Now, let's jump to the next. I got two more that I want to discuss with you. I actually will. I can go right in order here. I'm going to go right to number 6 off the worksheet. Number 6 is 4x squared plus 8x minus 5. Now, this one's got something different going on. But we'll get to there, okay? Not going to jump the gun. We're going to do things in order. Number 1, check for greatest common factor. Now, guys, remember, I've said it already a couple times, the small number kind of is in control of if there's a GCF or not. Well, the small number is 4. So we start with 4. 4 does go into 8 evenly. That's looking good. 4 does not go into 5 evenly. Out. Please remember, 4 is not the only number. 2 goes into 4 as well. So we check 2 a minute. 2 goes in. Does 2 go into 8? Yep. Does 2 go into 5 evenly? No. Greatest common factor is off the table. Okay? We are in a trinomial situation where a number's in front, and that creates some issues. We are going to break this up. And here's what the issues start right off the bat. I personally don't know if these first two pieces are going to be 2x, 2x, because that multiplies to 4x squared, or is it going to be 4x and x? I don't know. So I'm going to start with 2x, 2x. Because it's either going to work or I'm going to know it's going to fail quickly. Okay? Now, here's the trick. Now, that's a negative 5. There's only one way for a negative to happen over there is if one of the numbers is plus and one of them's minus. And another thing that makes this problem a little bit okay, there's only one way to multiply to 5. 5 and 1. I just don't know if it's plus 5 and negative 1 or plus 1 and negative 5. I don't know. So I'm just going to throw in there 5 and 1. Okay, now I've done this in class before with you. I'm like, answer's on the table. There it is. Check it. Is it right? Is it wrong? You know? And I wish I could hear you being like, yes, no, no, yes, whatever. Can't see, but we'll just deal. So you guys, you should be checking this answer. Really, the only thing that's like up in the air is like, does that 8 work right now? Is that part of this problem? If you distribute 2x times 2x is 4x squared. Yes. 5 times negative 1 is negative 5. Yes. It's the big outer, inner. Got to check that. 2x times negative 1 is negative 2x. 5 times 2 is 10x. 5 times 2x. 10 and minus 2 make positive 8. This is the right answer. You guys, you have to be prepared that that might not be the right answer. You have to be prepared that you might have had to switch the signs on the 5 and the 1. And you might have had to prepare for the fact, hey, guess what? 2x and 2x didn't work. It's going to be 4x and 1x. So it's just one of those things. But we got the right answer there. Okay, we're going to do one more, and I'm actually going to jump ahead to question 8. And that's going to be the last one I do with you guys in this video segment. I'm already at 24 minutes. That's kind of too much, isn't it? But I wanted to get all the review out of the way, and you can like say, I got this, and skip it if you need to. The next video I make is going to get into the actual lesson that we were about set to do right before we got the information to school's out. So, okay, so question 8 is 8x squared minus 4x minus 40. So we're in another trinomial situation here, people. And we're going to check, obviously, as normal, for our greatest common factor. Don't care the problem. I think I've made that clear. GCF is #1 priority. Well, as I look at this question, now remember what I said. Small number controls. The small number is 4. It doesn't have to be the first number. People are like, well, if it's not the first number, it doesn't work. Like, it's the small number. 4. Does 4 go into 8 evenly? Yes, it does. Twice. Does 4 go into 40 evenly? Yes, it does. Folks, 4 is the GCF. So we're going to take out a 4. 4 goes into that, 2, so 2x squared. 4 goes into that once, so minus 1x, or I just write minus x, of course. And 4 goes into that minus 10. 4 goes into 40 10 times. You guys, that's still a trinomial. That still has the look. X squared, then an x, then a number. We have to try to factor it farther. We leave the 4 where it is. Here's the nice thing. There's only one way to multiply to 2x squared. 2 and 1, okay? So we're just going to put 2x and 1x. Now, that's -10. To multiply to a negative, one sign's got to be plus, one sign's going to be minus. So I'm just going to kind of throw in a plus right here and a minus right here, and I'll tweak that if I need to. Now, listen, there's 2 ways to multiply to 10. 1 and 10, which is not a popular one to think about all the time, and 2 times 5. Listen, 2 can't go here. And here's why. If this is going to work, it's going to be a 5 here and a 2 here. 2 can't go here because if I have 2x plus 2, there's a greatest common factor right here. There's not a greatest common factor in this part of the problem. The greatest common factor already came out of the problem. There can't be another one. So if this is going to work, it's got to be 5 and 2. Again, I might have to tweak the sign, but it's got to be in that order. And if that doesn't work, then I got to go to my 10 and 1 combination thing. So I'm checking this. Answers on the table. I already know the 2x times x is 2x squared. I already know 5 times -2 is -10. I'm checking this, which is technically -1. This part of the multiplication is -4. This part of the multiplication, -4x, excuse me, is +5x. Now you guys, -4 plus 5 is 1, not -1, +1, which means I have my signs wrong. I need to switch this to minus, switch that to plus, and just recheck everything before I call this final and end this video. The 2x times x is still 2x squared. The -5 times +2 is still -10x. This is now +4x on the multiply. This is now -5x. Folks, 4x minus 5x is -1x. We check off now. So, there is some of the factoring review that we did at the start of our class. And that's about all we got through, but I mean, and it's not like you know, all of you forgot every detail. It's just that if I'm going to feel comfortable moving forward with you, we got to make sure that we reviewed our factoring capability. So you watch this video as much as you need. 30 minutes almost is too much. I understand that. I try to keep them to 15 to 20, but you know, sometimes it doesn't happen, and you don't have to watch them all in one sitting. I'm just trying to do this. You know how I am. I can't just let something go and say, well, there, I did half the job. You know I'm all in or no in. So I'm all in here, folks, and I want that to look good for you. So pause the video wherever you need to, review it. You can ask me questions via email, and maybe if it comes to it, we'll have to do a little online Zoom session right down here in the old basement classroom, and we can ask some questions together, and I'll work some things out. So we'll see how it goes. Again, thanks for tuning in, everybody.